Hello, my name is Ryan Schumacher and I'll be presenting my project on coral health improvement for my food quality management course. The following slides will represent the defined phase of my project. My original problem statement was that my Montipora digitata coral is currently in a poor state of health. Been very little growth and actually some die-off in the last 3 months. Typically these corals are actually pretty hardy and grow rather quickly. My goal, I've actually updated. Of course, I'm going to identify the optimum growth environment and water parameters to eliminate die-off and create visible growth, but I'm actually increasing that due to, as you'll see later on, that I had better growth than I thought. So I want to get more than 7/16 of an inch growth from here until the end of the project, which is a 25% improvement. In scope is my single Montipora digitata coral in regards to its health, including die-off and growth rate. Items out of scope include all other corals, fish, and invertebrates in the tank. The relevant metrics of my project are coral die-off and growth rate, measured in total inches of growth, starting on September 15th and ending on December 1st. My target is to eliminate die-off on my digicoral and get a minimum of a quarter inch of growth on any single branch of the coral. Some of the strategic goals of this project are that the knowledge gained and procedures used while I'm improving my coral health I can use to implement on other corals in my tank. This is my process map called a SIPOC, which stands for Supplier Input Process Output Customer Diagram. I've also included critical to quality column to help explain what's important about each step. My first supplier is the tank heater, which is going to provide input for electric heat into the tank, which is going to keep the process of my main water temperature in parameters. Output will be the water temperature will be where the customer, the fish and coral like to have it, and what's critical to quality there is that the water temperature is stable and within limits. The second supplier is going to be human, me, adding fish food into the tank via a process of feeding the fish, which will provide an output of fish excrement and excess food, which actually ends up being food for the customer of the coral and different scavengers, crabs and snails in the tank, and that's going to be critical to complete the nutrition provided to the fish and coral without providing excess waste. Third step is the fish and human as a supplier of fish excrement or excess food to the process, which is feeding corals, and the output is energy to the coral and excess nutrients, and the customer there is the coral and then tank water quality. Critical to quality there is the complete nutrition to coral without excess nutrients again. Then we go to lime water, which will provide an input of alkalinity and calcium. The process of that is to maintain that level. The output is water quality, customer being the fish and the corals there, and the critical to quality there is a stable alkalinity and calcium being within limits also. And then we have the light fixture providing input of light energy to the process of sunlight, artificial sunlight for the coral, which is an output of energy for the coral. Customer being the coral itself, and critical to quality there is the light spectrum, intensity, and duration. This includes a chart of my critical milestones and deadlines. Briefly, the project started at the start of class, August 22nd. I'm in the define phase, which started on the 22nd, running up until the beginning of the measure phase, which begins on September 26th. That runs for about a month, and then it begins running concurrently with both the analyze and the improve phases starting on the 24th of October with a goal of completion on December 11th. I've got several problems and some theories to discuss on what I might do to solve the issues. First being water temperature. Proper water temperature range is critical so it doesn't stress the corals and keeps in a range that maximizes the coral's metabolism rate. So I need to have good control of a water heater. I need to look at my feeding regimen to make sure that the fish and coral are fed enough to satisfy their calorie requirements, but they're not overfed. As I discussed earlier, uneaten food, when they're overfed, can be converted into breakdown products through bacteria and other mechanisms that are harmful to the fish. These can include ammonia, nitrates, and phosphate. So I need to determine a measurement or a way to find out when the fish are full. I need to also look at water parameters, specifically alkalinity and calcium. They're actually the building blocks of coral skeletons. Without them, the corals cannot grow. So I need a proper dosing regimen for those water parameters and a way to monitor them as I go. And then last, I'll be looking at light. Light actually provides energy for the zooanthia that in turn, through a symbiotic relationship within the cells of the coral themselves, will provide energy to the coral. So incorrect levels and spectrums of light will actually increase or decrease how they're living. So I need to look at the duration the lights are on, the type of bulb, spectrum I'm using, and the intensity, and hopefully a way to measure the intensity of the lights, of which I'm not sure how I'll accomplish yet. The following slides comprise the measure phase of my project. Here's my data collection plan for my project. As you'll see, I'll be measuring how much the coral has grown. I'll be measuring that in total growth per week, every week, using pictures, Adobe software, and a ruler. I'll be measuring what the temperature of the water is, and that is actually done with the data logger and a temperature probe in the tank, done once per minute. I'll be measuring the pH of the water. Again, that's using a probe that's in the tank and a data logger measuring once every 10 minutes. We'll be looking at the alkalinity level of the water and the calcium level of the water, and both of those are done using a test kit once per day and logged. As a refresher on how I measured my coral growth for my project, I used a camera to take pictures weekly, had the cameras placed in front of a grid to get the scale of the picture. I then analyzed the photo in Photoshop and measured it in pixels of growth, and then was able to take that pixel and convert it over to an actual inch measurement. Using the previous measurement method, I measured the baseline performance of my growth. It was totaled out to be 0.15 inches over a period of 3 weeks, which was equated to 0.05 inches per week. My goal, knowing that I actually am getting some good growth, even more than what my original problem statement mentioned, is to actually improve that by 25%. So total growth from here on out over the next 7 weeks would be 0.4375, 7/16 of an inch, which would equate to 0.0625 or a 1/16 of an inch per week. Here are the pictures of the coral growth that I've been taking over the last few weeks. We start with week 0 and we'll end with week 4, and then a final slide which shows the beginning to end growth. In each slide you'll see from week to week the growth, and focus on the red line, which is underscoring as a baseline, and look from above that, so the vertical growth from that red line, and that will equate to how much growth I've gotten each week. This is focusing on the area of most distinct growth that I've noticed. This slide shows the baseline performance growth of my coral, showing week 0 on the left and week 4 on the right before I made any improvements. To measure temperature and pH of my tank, I'm using a Neptune Systems Apex Aquarium Controller. It's a compact logic controller. It's got inputs and outputs for various measurements such as temperature, pH, and outputs to control outlets such as heaters and tank lights. It logs the data, and it's actually connected to the internet to give me information. The temperature and pH probes are mounted in the tank, and they record every 10 minutes. Data is then logged and stored in the controller so I can retrieve it at a later time. And the reason I'm actually measuring pH is because there's a link and correlates to my dosing regimen of alkalinity and calcium. This is the chart of my temperature over the duration from September 26th to October 15th. The above chart, you can see the overall trend over the whole time there. You can see kind of the high points, the low points, and as the heater actually cycled on and off. Below that, I've got a little more zoomed in detail so we can see what's going on. You can see it actually is measuring it every 10 minutes. You see a little step pattern there. Don't be alarmed by the sharp jumps that go up and down. It may look like it's actually out of control, but it's not. If you actually look at those measurements, you're only looking at a degree, maybe a degree and a half of variation as the heater fluctuates on and off. Here are the charts of my pH data log. Over the top you can see the major trends as we go. Notice some of the spikes. Notice the waves as it goes up and down. What you're actually seeing there is it actually fluctuates from daytime to nighttime based on respiration of the fish and different things that are in the air. And then as you zoom in on the detail, you can really see some of those spikes. And what you're actually seeing in those spikes is when my auto top-off system that tops off evaporated water, I've actually got a mixture of alkalinity and calcium makeup solution in there. And when I do that, it's very caustic or alkaline solution, and you can see Every time that dose is in the tank, I get these really big spikes, fairly localized and very short in duration, but it could potentially be a problem. To measure both alkalinity and calcium, I'm using a Hanna Checker colorimeter, and it uses a fixed wavelength LED and a silicone photodetector to actually measure the color change that is due to chemical reagents. You can see a little bottle that I've got water mixed in, and you put the chemical reagents in there. It causes a color change. Close the cover, push the button, and it gives you a readout of what the value is. Here's my chart of daily recordings of alkalinity in the tank. It's measured in DKH, or degrees of carbonate hardness. You can see the average was 7.3, standard deviation 0.76, min and a max of about 5 and 8.5. Doesn't seem like much, but alkalinity, can have a big effect on what's going on in the tank. This is my chart of daily calcium readings done in the tank. Not too bad fluctuation there, although from 350 to 500 that could be causing some stress on the corals as well. Average of 426, standard deviation of 41, and a min of 340 and a max of 500. Here's my cause and effect diagram, or fishbone diagram. You can see my original problem statement on the right side there. You can see the major ribs of the fish are the 4 parameters that I'm kind of looking at closely: alkalinity, temperature, calcium, and pH. A lot of what you'll see here, if you pause this presentation, just take a moment to look at it, is mostly values that are either too high or too low, out of the range of good temperatures and alkalinity ranges for the corals. And then you'll see other things such as too much fluctuation, or the interaction, as I described earlier, with my auto top off and spikes in those values. These are my potential X's, or theories, I want to test over the next few weeks. First is water temperature not being ideal. I'm going to research what that ideal temperature should be for corals, tune my temperature loop to try to reduce fluctuation. I want to get that done as a goal of within 1 week. The pH of the water is not ideal. Again, I'm going to research that ideal pH level for corals, tune my auto top off loop that I've talked about earlier, try to stabilize that, and my goal is to get that done within 2 weeks. Both the alkalinity and calcium, since they're so linked together, I'm going to research those levels as well. Work on, of course, tying in with the auto top-off tuning, and then also I'm going to try and adjust the concentration, get that where I need to be. Timeline, get that done in the next 1 to 3 weeks. And the last one is light bulb. That one's a little unique. That one is just like what I consider just do it. It's a quick, it's easy, little investment, great rewards. So I'm just going to get some new bulbs and get that taken care of. This is my updated milestones and timing slide. You can see the green hash marks of time that's elapsed. We're now mid to late October, so I'll be moving on to the analyze and improve phase of the project. The following slides comprise the analyze and improve phase of my project. To analyze the temperature control of my tank, I created an individual moving range chart. You'll see the center line in black at 77.5 degrees, control limits in red lines, and the upper and lower spec limits in green lines. You notice that the capability index is 1.16, which means it is capable, but not extremely capable. As you can see, I've got a couple spikes above the control limits there on the left-hand side of the chart due to some warm days in the house, since my tank does not have chilling. However, because it is fairly in control and none of the points really were detrimental to the tank, based on basically industry standards for tank temperatures, I chose not to use this as something to improve on. This is my analysis of pH data. Again, center line is in black, control limits are in red, and specification limits are in green. Capability index is 1.06. This is just barely capable of a process here. You do see I do have a couple spikes outside of the specification limits. However, those are just kind of anomalies due to placement of my pH probe and really close to where I add my high alkalinity solution in the tank. And you can see it quickly comes back down once the solution has a chance to circulate in the tank. So because it's at least barely capable, I chose not to look at this further for improvement. This is my analysis of the alkalinity process capability. I used, again, IMR charts to analyze this. Center lines, upper lower control limits are labeled on the charts. For these, my upper and lower control limits are equal to my upper and lower specification limits. Had a capability index of 1.04. So it is capable, it is within control. However, literature says that I should have my alkalinity at a level of about 9 to 9.1, where it's actually at a 7.3. So this is the one aspect that I did choose to improve upon. This is my analysis of calcium process capability, again using an IMR charts here. Center line, upper lower control limits are labeled. Again, upper and lower control limits are equal to upper and lower specification limits. This one, capability index, is actually just a little bit below 1. However, because I appear to be pretty much within my control limits most of the time anyways, and the center line is right at 426, which literature says it should be about 420, I chose to, again, focus on my alkalinity readings for improvement. This is my process failure mode effect analysis table. It's an attempt to put a risk priority number and objectively quantify the problems that I'm already talking about addressing with the tank. As you can see, my auto top off roll there, it was 105, one of the highest values there. That one I've already identified that I'm going to try to fix by working on raising the alkalinity in the tank. And then you can also see the tank lighting at the bottom being a high number, which was a just do it. I just replaced the bulbs on that light to help. This is a slide showing the improved portion of my project, focusing on the alkalinity using IMR charts with upper and lower spec limits equal to control limits. Not very well in control. Capability index is a 0.33, which is very poor. A lot of lines above and below my control limits. So you can see, on the left side there, where it was low, about a little over 7. On about October 22nd, I started trying to shift from 7 points of alkalinity up to trying to get to an average of about 9. So you can see I had a really big spike in it there for a while. And then I had to slowly let it kind of come down naturally on its own. And then you can see where I dosed more alkalinity again, and it kind of spiked up, slowly came down. And you can see over time I was able to slowly get it back in control and narrow it down. But by that point, it was a little too late. And as we'll see later on, I think it had adverse effects on coral growth. In this chart, I removed my out of control points and recalculated my capability index. It turned out to be nearly 1, so almost capable. I can verify this by looking at the last week of recorded data and the pictures that I took, and I actually had 0.08 inches of growth that last week, which actually exceeds my goal of 28%. Here you see my coral growth over the improved stage of my project. Week 4 on the left, which is where I left off at the measure phase, and then week 10 on the right. It looks like some decent growth, but as we look at the numbers on the next slide, we'll see that it wasn't quite meeting my goal. Here's the calculations for my improved stage of my project. I had a total growth of 0.217 inches over a period of 6 weeks, which equals 0.036 inches per week, which is about a little over half of what I wanted for my goal. It's actually worse than what my baseline performance was. One attribute of that is because of the alkalinity problems I had that I explained a couple slides ago. This is a summary of my theories tested. First one was water temperature, at which I found the process to be in control and capable after analyzing the data. Same was true with my pH. Alkalinity was one of my big upsets with this, as I tried to raise the alkalinity to 9.0 from an average of 7.3 on my baseline performance. I overshot the target, and it took me time to get up the process variable actually settle back down and get in control. I think this caused a lot of reduced growth rate because of that instability in the process, and then created a process that was not capable. The calcium levels of the water, I said were in control and capable enough for what I was doing, and I wanted to really focus on alkalinity anyways. The other problem I had that isn't really shown in data here, but the light fixture I have actually broke on me in early November, and what ended up happening is I couldn't get enough light on the tank and control it well enough. So I think that also kind of set back the coral growth for a while there until I got it fixed. As you can see my project schedule, I'm now most of the way through the analyze improve stage. From here on out, my future plans would be to keep focusing on getting that alkalinity measurement in control and see if over the next couple of months I can get some better growth going on there. Just due to the slow coral rate, it's kind of hard to get data quickly. This concludes my presentation, and I'd like to invite everyone's comments and questions and constructive feedback. If you can leave that in the post, that'd be great. Thank you.